Hello everyone, welcome to this next video on complex analysis. In this video we shall take question from GATE 2003 and it is of 2 marks. The question says, let fz be defined on the domain. This E is given to be a circle having center at 2 iota and having radius 3 and this function is defined on this domain E over it and as well as on its boundary represented by this del E. Then they are saying which one of the following is always true. So we have to look for which of these is correct. So here notice that in every option they are saying whether we have the modulus of function attains a maximum or a minimum. Maximum and minimum and a minimum. So for that, if you notice that we have these two results, maximum modulus theorem and minimum modulus theorem. So if you knew the correct statement to these two theorems and if you make proper observation, you can get these two marks very easily. So let us first look at the statement maximum modulus theorem. It says that if fz is analytic inside and on a simple closed curve C and is not identically equal to a constant, then the maximum value of this function occurs on the curve C. So that means here in this case they are saying our function f that is analytic where on C plus its boundary, right? So it's analytic within C and on its boundary. So we have something like this. For this question we have this curve as E and its boundary defined to be del of E. So that means we have E union with del E, right? So this is the given portion. So the theorem says our function, if any function is analytic inside and on a simple closed curve C, that means we are saying f is analytic on this E union del E and is not identically equal to 0, and this function f should not be 0. In that case, the maximum value of this modulus that occurs on C. This is one result. Another result is if f of z is analytic inside and on a simple closed curve C. So again we are talking about C union with its boundary, right? And this is not equal to 0. Here the condition is of not equal to 0 and here the condition is that of the function not being equal to a constant. Then they are saying the modulus of this particular function attains its minimum value on C. So for the first option they are saying our function is analytic on E and f of z is not equal to 0 for any z in E, then the modulus of f attains its maximum on del E. So now for maximum we should have this result, f of z should be analytic on E as well as on its boundary, but this condition is not given to us. So this options goes to be correct, goes to be the wrong option. Then let us see about the second option. Here they are saying the modulus of function attain its minimum value on the boundary and we are given f of z to be analytic on E as well as on its boundary. So here for the minimum value of C, you see the condition f of z not equal to 0 is missing. So this option is also incorrect. Moving on to third option, they are saying if f of z is analytic on E and is continuous on E as well as its boundary, then modulus of f attains its maximum as well as minimum value on its boundary. So now here they have not mentioned the analyticity on the boundary del E, right? And they have not mentioned anything about f of z being not equal to 0 or being constant. So this option is also incorrect because we cannot make any statement about maximum or minimum value of this function modulus of f. So we are left with only one option, so that is correct. So let us have a look why it is correct. They are saying if a function f is analytic on the curve and on its boundary, and it is not equal to 0 for any z on this particular thing, then the modulus of function f that attains its minimum on the boundary. So obviously this is the same result as this theorem. So option D here is the correct option. So I hope you understood this question. Thank you for watching.